Hey guys, welcome back to the channel. Hope you all are doing good. So I will discuss one problem in this video because the other remaining problems in greedy topic are hard level, and it will take some time for me to understand how to explain my solutions. Some of them I have understood and got the answer, but some of them even I need to answer it first. So let us solve one problem in this video. Before we start the video, I would quickly like to tell you about this amazing ebook. This is an ebook on data structures and algorithms, and it is written by a software engineer himself who has worked in many MNCs. And even HR questions, 15 plus HR questions are in this book. This book is extremely neatly written and organized very well, and there are almost all important topics. So as you can see here, sorting, searching, and tree data structure, graph, backtracking, all of them are present over here. And I think it's a very good purchase. It is available for a very affordable price. Please check the link in the description. So let us start with today's problem. Today's problem, picking up chicks. This problem was actually asked in Google Code Jam 2010. So it is actually quite a famous problem. I encourage you to first read the problem by yourself, and then maybe I can start saying. So pause the video and then come back. So I hope you have read the problem. So what is the problem statement? Basically, there are n chicks, okay, and they are located at certain coordinates x of I. All of them have certain speeds v of I. There is a barn at a location B. So how to represent all these things? So I'll just move myself up. So let us say this is the x-axis, okay? And let us say there are some chicks here. And let us say there is a barn over here. So this is barn, and all of these are chicks present. Location of the chicks. This is the x-axis, okay? And each chick has its own speed v of I. What has to be done? These chicks have to reach the barn. These chicks have to reach this barn. What does it mean, reach the barn? It has to cross this mark B. So it has to cross. When it crosses, it means it has reached the barn. We have to swap the slow chicks with the fast moving chicks in such a way that at least k chicks can reach the barn. What did I say about swapping? Swapping, why are we thinking about swapping? That is what the problem is asking, right? See, you may think of chicks as points moving on a line. Okay, even if 3 or more chicks are at the same location next to each other, picking up one of them will only let one of the other two pass through. Any swap is instantaneous. That means what does this paragraph mean? Basically, a slow chick is an obstruction for a faster chick if the faster chick is present behind the slow chick. Let us consider two chicks, C1 and C2. Now this is a slow chick and this is a fast chick. Okay, there is a chance that if this fast chick C1 is swapped with fast chick C2, that means if the arrangement becomes like this, then this chick will reach the barn. Like that, we have to find out what? We have to find out the smallest number of swaps required so that at least k chicks reach the barn. Smallest number of swaps required at least for what? At least k chicks reach the barn. See, let us consider this example only. Okay. Forget all the values and all. Let us just take a random example. Suppose there are 5 chicks, C1, C2, C3, C4, C5. Now, how to calculate if a chick can reach the barn or not? It has to reach the barn within a time equal to t. I forgot to mention that there is a time t. So what is the input? Input is going to be, first there are 4 variables n, k, b, t. N represents number of chicks, k represents how many chicks we require, at least k chicks we require to reach the barn. B represents the position of the barn, and T represents the time in which all these things should happen. Next 2 lines will be position of the chicks and speed of the chicks correspondingly. So this is input. So input is clear, right? You can read the input from here only. Pause the video and read the input. Okay. So now let us consider there are 5 chicks, C1, C2, C3, C4, C5. And first we will start with chick number 5. Why are we starting from the last? Because then we will get to know how many swaps are required. Because it is logical, right? See, barn is here and this chick is present over here, the last chick. If I can move this chick faster, then only I can comment about the remaining chicks. It will become easy for me. It becomes easy if I start from the last. So let us start from chick number 5. Now, how do we know if this chick can reach the barn or not? We have to obviously calculate the distance between the position of the barn and the position of the chick. So what is the distance you have to calculate? You have to calculate distance between position of the barn and position of the chick. So that is B minus X coordinate of the chick. Okay. But how much distance can the chick go? Speed into time is equal to distance. We know the speed of each and every chick. We know how much time it is given. The input is given time. See, time input is given, right? So maximum distance it can go, maximum distance a chick can go is equal to time into speed of the chick. So basic distance formula, distance is equal to what? Speed into time, right? This time is input and speed is speed of each and every chick. So basically we have to compare 2 quantities, maximum distance the chick can cover and how much distance it has to cover. If the maximum distance the chick can cover is greater than or equal to the distance the chick has to cover to reach the barn, then we will consider that. Then it is a possibility. Then we will concentrate on that chick. So for example, in this case, if chick number 5 can reach, okay, so chick number 5 will reach the barn, we don't have any problem. Okay, now let us come to chick number 4. Suppose chick number 4 cannot reach the barn. When I say cannot reach the barn, what does it mean? That the distance between barn and the position of the chick is greater than speed of the chick number 4 into time. Just remember 2 things: maximum distance a chick can travel and how much it actually needs to travel to reach the barn. So these 2 quantities only we have to compare. So let us assume chick number 4 cannot reach the barn. And similarly, we will assume chick number 3 also cannot reach the barn. But we will say chick number 2 can reach the barn. Now what to do? See, if chick number 2 has to reach the barn, then the obstructions, that is chick number 3 and 4, 2 can reach the barn, 3 and 4 cannot reach the barn. So I have to move these 2 chicks behind this chick number 2, right? Because if chick number 2 has to reach the barn, this obstruction should not be there. So what is swapping here? This swapping means removing the obstructions for the chick to reach the barn. So I will swap chick number 3 and 4 behind chick number 2 in such a way that they come behind chick number 2. So my arrangement might look something like this. So my C2, that is chick number 2, should be ahead of both these two. Okay. Now similarly, let us assume chick number 1 also can. So for chick number 1 to reach the barn, the obstructions are still the slower chicks only. The slower chicks are chick number 3 and 4. So if chick number 2 was here and chick 3 and 4 were here, we just swapped chick number 2 with 3 and 4. So 2 swaps we did. Now the position is something like this. Now I'll show you the position. Just listen to me carefully. Now I'll show the position. Now position is something like this. See, this barn is there. Chick number 5 has reached long back. Chick number 2 has reached. Now chick number 1, 3 and 4. They are left. Now these two are slow chicks. They can never reach the barn. But this can reach the barn. So again you have to swap it with these two so that the arrangement becomes something like this, and chick number 1 is ahead of both chick number 3 and 4. So again swaps needed is equal to 2. So for chick number 2 to reach the barn, 2 swaps. Chick number 1 to reach the barn, 2 swaps. Why am I emphasizing on this? Because the number of swaps we need has to be cumulatively increased. That is important. So this was the problem statement. It is simple, very simple. Just how many swaps required, what you should calculate, two values: maximum distance the chick can travel and how much distance is needed to travel. Compare these two. So I will show you my code now, you'll understand better. See, take the input n, k, b time. N is number of chicks, k is how many we want inside the barn. B is the coordinate of barn, the x coordinate of barn. Time is the time required to do all this. Now x represents the coordinates of the chicks, v represents the speed of each chick. Okay. Now what are these three variables? Count, swap, not possible. Count represents how many chicks can reach the barn. Swaps represent how many swaps we have to do so that those many chicks can reach the barn. Swap represent how many chicks can, swap represents what? Swap represents how many times we have to swap so that a faster chick can reach the barn. Swap represents how many times we have to interchange slower chick with faster chick. We have to swap those two. And what is this not possible? Not possible keeps the count of how many chicks can never reach the barn. So let us traverse through the array from back side because it is easy. It will be easy for us to know how many swaps required because we need slower chick, faster chick. If at all we come across a situation where a slower chick is present ahead of a faster chick, then it is an obstruction. That is why we have to start from reverse. That is from end of the array. So two variables are there. Distance needed. So how much distance is needed for a chick? Distance possible, how much distance the chick can cover. So these two values you have to find out, calculate. Okay. Then after finding, we have to compare them. If distance possible is greater than distance needed, greater than or equal to, then we will increase the count. And if there is a slower chick present, then we will add it to swaps. We will add all the slower chicks to the swaps. That is what I was telling you. Cumulatively, we have to keep adding the number of slower chicks. I gave the example, right? I gave the example of chick number 2 and 1. For chick number 2, there were 2 slower chicks ahead of it. So I swapped it twice. But for chick number 1, also there were 2 slower chicks ahead of it. So again, I have to swap them twice. Please rewind the video if you didn't understand. You will get it if you see it maybe twice. So if this condition is false, that means the chick can never reach the bar. So increase not possible by 1. If at all count becomes greater than or equal to k, break. If count is greater than or equal to k, print out swaps. So this is how you have to print case number, the number and swaps. Otherwise, if this condition is false, that means it is not possible to bring at least k chicks to the barn. So print impossible. So again, pause the video and take a look at this part of the code. This is, and especially this is most important line. This if statement represents if there are slower chicks, but we encounter a faster chick, then we have to swap the slower chick with the faster chicks, because the slower chicks will become obstruction. I tried my best to tell you in a very simple way. I first explained whatever I thought. I thought I could give you like a visualization initially, but the coding is very simple. It's actually an easy problem. So I hope you could solve the problem, or you can do it by yourself now. I encourage you to do the same. Okay, so solve it by yourself. If you are new to the channel, please share the video with all your friends. Subscribe, and I make such videos only, programming content only. So please subscribe. It will benefit you in the future or whenever. And please share it with your friends. And like the video if you really like my work, and it really motivates me. So that's all for this video. Take care, stay safe, keep learning, keep growing, and stay tuned. Bye.